10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage des ESR et décollage. Les paramètres à bord sont normaux. Trajectoire nominale, les paramètres à bord sont normaux.
And we are off. Satellites 33 and 34 in Europe's satellite navigation constellation have started their journey on board the continent's Ariane 6 rocket. Galileo satellites are on their way. We are supersonic. We've broken the speed barrier. The Range Operations Manager is telling us that everything is going according to plan. And we are hearing the rumble of the rocket as it flies over our mission control center about 16 kilometers away from the pad. It's taken over a minute, about a minute and a half for that sound to come to us. Right-hand side of your screen, we're looking at the telemetry information coming in from our rocket. David, that's the curve on the top right-hand side?
That's right, yes. So the green line is the prediction and the yellow line is the actual position of the launcher. So we see that we are right on the spot.
And below that our altitude, and we're presently 43 kilometers and climbing above Earth. Our distance from the pad, if you were to draw a straight line, and our speed. Right, our boosters are doing all the work, David, aren't they?
Yes, that's right. About 85% of the thrust needed, and they will be separating in just a few seconds at 63 kilometers altitude.
Trajectoire nominale. Séparation ESR.
And we have confirmation there from our Range Operations Manager that those boosters have been separated as planned. So, we are losing weight. As you say, that's the name of the game, to jettison as much mass as possible as we go through the flight. And we're burning 3 engines, as we said. We switched on the Vulcan 2.1 on the ground, on the main engine, and the boosters. But as we said, the boosters really were doing all the work. Now, we don't need them anymore. The fairing at the top of the rocket is where our satellites are housed at the present time. That will be the next thing to be jettisoned. What's it protecting us from?
So the fairing protects the satellite on the ground from dust and humidity, and then during the launch from the acoustic vibrations of the launch, and also, of course, from the friction and the heat during the ascent through the dense parts of the atmosphere. And it will be separated once we don't need it, meaning at around 110 kilometers, so very soon.
There we go, that's how it looks.
Séparation des coiffes, trajectoire nominale.
Confirmed by the Range Operations Manager, who's also telling us that the trajectory is normal. And you can see there our altitude, 116 kilometers now above Earth. So we've crossed what we call the Kármán line, if you like, the border with space. And we can see our satellites for the very first time, David, and they can see space.
Yes, that's right. The image shows the launcher with the satellites and the dispenser on top of the launch vehicle adapter, the black cone on top of the launcher. This is a simulation. These images are a simulation based on the outputs of the trajectory calculations, showing the launcher as it should be right at this moment.
Indeed, the simulation is very much a very useful thing for us to be able to see. We call it the 3D or the CGI images, and they use the gaming software Unreal Engine to create those images. So, as we said, our trajectory on the right-hand side, and below that you can just see actually the people there in the Launch Control Center, David, now watching the launch.
That's right. Their job is finished, but they are, of course, following the launch very closely.
So, we are burning the main engine. It's a great big tank of fuel. You can see it there.
Yes, it's 32 meter high, 5.4 meter diameter, and it's full with 154 tons of liquid oxygen and liquid hydrogen. The chemistry of these two elements leads to one of the most fuel-efficient combinations that exist for rocket propulsion, meaning that for a given amount of propellant, we will get the highest acceleration transferred to the launcher and to the satellites.
He's telling us that we've got 2 minutes left on the burn on the Vulcan engine. And it is indeed a powerful engine, isn't it, the Vulcan 2.1?
Yes, it's 135 tons of thrust in vacuum, and it burns the propellants in around 7.5 minutes, increasing the speed and the altitude. Today, we will go up to 5 kilometers per second with this stage and up to an altitude of 200 kilometers. And this engine actually has been optimized with respect to Ariane 5. The nozzle manufacturing has been optimized. There are some additive manufacturing elements that have been added, like the gas generator. And also we have added a thermal protection on the nozzle that we saw before on the launch pad to protect it from the heat from the boosters during the launch.
So you can see our altitude, 169 kilometers, so we're increasing our altitude and increasing our speed. At the moment we're 3.4 kilometers actually per second. And actually, we not only are we traveling fast and getting higher, but we're actually rotating, aren't we, very slowly?
Yes, that's right. There is a small rotation that is done in order to keep the heat on all parts of the launcher at the same rate. He's
telling us everything's going well. David, it's quite interesting actually, because we launched, didn't we, 2 Galileo satellites from the Guyana Space Center exactly 10 years ago today.
Yes, that's right. On this 17 December 2015, there was the launch of launch 6 of Galileo with satellites 8 and 9 that were launched, yes, exactly 10 years ago.
Les paramètres à bord sont normaux.
So everything's going well, coming up to the next main event, and that is the switching off of the
Séparation
main
LLPM.
engine. And we have confirmation that main stage has now been separated and jettisoned, and the Vinci upper stage engine has now switched on and the propulsion is normal. And we are being tracked now by the naval tracking station. It's actually on a boat, isn't it?
Yes, that's right. For today's mission, flying northeast across the Atlantic, there is no tracking station on the ground that can see this part of the trajectory. Therefore, we use a mobile tracking station that is installed on a boat, and we position the boat in the right place in the middle of the ocean to be able to follow